Hi there, everyone. We're about to start. Just giving people a couple of minutes to join. So we'll be starting in probably 2 minutes. Thanks.
Callum, it looks like everybody is all set if you want to go ahead and get started.
Awesome. Thank you, Tricia Lee. Okay, and thanks to everyone for joining. So my name's Callum Finlayson, and I'm Director of Data Preparation for DataRobot and formerly Paxata. A very brief introduction about myself. I've spent 10 years at Informatica prior to DataRobot and Paxata. So very much my background is in data management, sort of with a specialization in master data management. For the last 5 years, though, I've been with Paxata, and I started off over in New York City. And I just mentioned that because I started off in a relatively technical role and had the opportunity to work with many of our customers in many different verticals. So being in New York, there was a skew towards financial services, but there were obviously many other industries like pharmaceutical, healthcare, retail, many others. And I think the reason for that is pretty evident in that data challenges are across the board, not just a particular vertical. And then the other point is that it's not just machine learning. So data preparation for machine learning is what the topic is really today. But there are many other use cases in which data preparation can be used by organizations, and we'll explore that in a little bit of detail as we go through this. I certainly don't want to spend too long on the slide deck, but I think it definitely behoves us to spend some time just framing the problem, and then I want to spend some time telling you what I'm actually going to demonstrate today. So one of the reasons for Paxata existing is that, of course, we are trying to empower domain experts to prepare data irrespective of their technical expertise. So that's not to say that we're only focusing on business users and we don't want data scientists to use our product. Quite the opposite, actually. I think one of the deals that I was involved in that was quite interesting was Nationwide Insurance in America. And the reason I bring them up is that their data scientists were certainly some of the biggest supporters of the data preparation platform that Paxata provides to their activities, so to make them more productive. And so to that point, one of the challenges that organizations face is the outpacing of demand and of the supply for data scientists. The next 4 slides, and I'm going to skip through them very, very quickly, are really going to define the challenge that businesses have when it comes to AI, ML, and data preparation. And as I said, the demand, this graph is really showing that the demand for AI and machine learning is greatly exceeding supply from a skills point of view. So in conjunction with that, there's the promise of AI, which is tremendous. And more than 90% of companies today face technical difficulties when deploying AI models into production. And so if that's the case, they're unable to generate optimal business value from those initiatives. And a large part of that is 80% of the time spent on getting data ready. And I think that becomes very accurate, particularly when you start thinking about the democratization of this process and people without the deep technical skills trying to start preparing data. There's three main buckets and three main challenges that I think contribute to this 80%. And I'll talk about those briefly, but they're starting on the left-hand side being the explosion of the variety of data sources. Lots of different sources require lots of different people with lots of different skills and using different tools, different programming languages and platforms to get the job done. So that's challenge one. Challenge two, the data provisioning bottleneck. A lot of organizations that I've dealt with are either investing in data specialists or data engineers or adopting a traditional sort of ETL methodology where you've got business users dictating or requesting in the form of a business requirements document sometimes what their requirements are, and then those data engineers or the ETL developers go off and get them the data that they're interested in. Now, oftentimes through no fault of the data engineer or ETL developer, the business changes their mind or it's not exactly what they thought they were going to get. And so that's a very iterative, time-consuming process. And you can quickly see how that 80% number comes about. And then finally, the last point here is the changing business context. So the business context obviously influences the transformations, and there's not one size fits all. So they need to be evolving, they need to be agile, and they need to be able to be performed very, very quickly. Coming back to the final slide in this, so what can we do about it? And that is, what can we do about demand outstripping supply? So we've got the data scientists on the left-hand side, and then we have data scientists and citizen data scientists on the right-hand side. So by tapping into that untapped potential of many other employees within the organization, and also empowering the data scientists to not spend 80% of their time in a pandas data frame trying to manipulate data, and really preventing them from needing to spend the time in the data janitorial world and more in the developing predictive analytical models. The democratizing of this process too is really interesting, particularly when you put a context of both Paxata data preparation and DataRobot AutoML, and that's something that I'm going to be demonstrating today. So just as a final point, and this is really saying the same thing as the previous slides, but increasing the data scientist productivity and then empowering many other employees within the organization to democratize this process is really how we're going to address this demand and supply gap. As a very quick overview of the stages of machine learning, and I apologize for all of you on the call that already know this, but I thought it would be a good level set for anyone not familiar with the machine learning process. It's pretty straightforward. Stage one is the building model stage, and we're going to be going through this in the demonstration, so I just want to point this out. Stage one, we start with historical examples, and this requires data. It requires clean, contextual, consumable data, and that's what we're going to use Paxata for. Then we'll train and build models with AutoML using DataRobot, and we'll come up with a predictive model. So that's what we're going to spend a lot of time in the demonstration doing. if you move down to stage 2, we're also going to touch on this, where we're going to take new data, we're going to apply the predictive model that we've taken in training, all within Paxata, to create a predictive solution. So specifically, taking this slide in a little bit more detail, this is specifically what we're going to be going through today. I'm going to be starting off with some XML data. We're going to be, specifically, it's going to be web campaigns information, but more about that in a moment. I'm going to be enhancing it with some leads that I have in Salesforce. And then it's a bit of a spoiler, but I'm going to be missing some data, and that data is going to be residing in Snowflake. And so we're going to prepare that in Paxata for stage 1. And we're going to export it out, or rather create predictive models within DataRobot. The second part of the demonstration is going to be taking some slightly different data from those same sources, calling the predictive model that we've built in DataRobot in Paxata, and then exporting it out to a Tableau server to visualize in Tableau. And I want to show you a couple of capabilities relating to data preparation and Tableau. My final slide, this is really just another way of showing you what we're going to be performing in today's demonstration. I'm going to start with the problem hypothesis, which is really that we've got some web campaign information, and we want to know which leads will likely convert to become customers and which won't, so which ones to focus on and which to not. It's going to start, so that's really the green on the left-hand side. This particular slide is color-coded to show the journey, but to show the different parts of the process. So we're going to start off in Paxata, we're going to move to DataRobot, and then we're going to end up in Paxata to finally export out to Tableau. So if we start on the left-hand side, we have the problem hypothesis with web campaigns information. We're going to collect the data from all of those 3 different sources that I mentioned, XML, Snowflake, and Salesforce. We'll profile it, we'll prepare the data, and this is where we're going to spend a lot of the time in the demonstration. The next step, feature engineering. DataRobot has some fantastic feature engineering capabilities, but there's certainly an overlap in the potential for Paxata and the potential for business users to impart their expertise on a data set to create features. And so I'll touch on that as well. We're going to look at model building, exploring models, evaluating models, and then finally deploying the model. But it's going to be in a very abbreviated form to then move back to scheduling predictions. So without further ado, I'm going to close down my presentation and move on to my demonstration. Paxata is a web-based interface, and so you can see here that I'm logged in. I like to think of it being split into 2 main sections. So you've got the library here, which is where I store all of my data assets, and then I've got projects where I create the transformations and all of the logic that goes behind maybe joining a data set, selecting a subset of it, and we'll spend most of the time in this section of the demonstration. Because I'm in the library at the moment, there are various ways that I can sort and organize this data. And at the top, this top panel just gives me some of those options. So if I want to sort by where the data's come from, I can certainly sort that way. If I want to sort on a tag, I can do that. In fact, I have a tag set up called webinar. And this is the data. This is the XML data that we're going to be looking at for this particular demonstration. This XML file you can see is about 1 million rows long. I'm going to use the more actions here, and you can see, if you recall the last PowerPoint slide that I showed, one of the first steps from collecting the data was profiling it. And so this is our profile capability where we can say, well, I might not have time to go and interactively discover all of the different characteristics about this data set. But if I import it into Paxata, I can get an automated profiling report created. And so you can certainly do this from whatever data you bring in. This data I've already brought in. This is my XML file. We've got for the record, we have very, very complete and very good XML parsing along with JSON. So if you do have complex data structures in that format, we will sort that out for you, and it's a pretty interesting capability from a Paxata perspective. That was a little bit of a segue. This particular data set and this profile has a number of different columns based on the different things that we want to report on. The actual rows of the data is reporting on the specific columns of the data set. So I can see that I've got 15 columns in my original data set, and these are the characteristics of them. This can be customized to whatever you want, but you can see some of the interesting things like the top 5 values within a particular column, the minimum and maximum string length, and there's various other characteristics. Going back to my library though, and sorting this, or drilling down on just the data set I'm interested in, the first thing that I'm going to do is create a project. And I'm going to call this marketing analysis because that's what we're doing. By doing this, it takes me into my project section. So you can see up the top here, I'm now looking at projects. And then on the left-hand side, there's a number of different tools that I have available. Now I'm going to be going through most of these tools today, but some of them, obviously, we're not going to have time to explore in a great amount of detail. The first thing I always do whenever I bring a data set into Paxata is turn on pattern highlighting, which shows me some of the repetition within a column, some space highlighting, which shows me the spaces. So you can see last name there has a yellow bar next to it, which is just indicating the fact that this has got some spaces in it. And then range highlighting affects numeric columns. I don't have any numeric columns on the screen at the moment, so it's not appearing to do anything, but I'll point out what that does in just a moment. Once I have my data in Paxata, I can do what we call filtergrams. So if I click on any of these columns, I'll start with the first column here, campaign. I can click on the A to Z button and it shows me the different unique values in this list. So I can very quickly see that we've run 300 campaigns in what looks like financial year 19. So that's interesting to me. I can drill down on any specific values that I want. So if I'm only interested in maybe Q1, Q2, Q3 of the direct white paper in EMEA, you can see now that I've selected these 34,000 odd records, you can see that I'm just selecting those values here. Now, because I'm a domain expert, and we need to make that clear, I'm a domain expert for this case anyway, for marketing, I can see quickly and clearly that this campaign column, even though there's 300 different campaigns, there are multiple pieces of information in this column. So what I'm going to do is actually split this up. So using the drop-down menu on this column, and every column has a drop-down menu, I'm going to go ahead and perform a split. I've got 3 different options to be able to split a column. So 3 different strategies, really. I could match a separator or a delimiter. I could use a regular expression if it was a complex use case, or I could simply use the length. In this case, nice and conveniently, I have an underscore which separates all of these. And by default, we create 3 columns, but you can see very clearly I'm going to need more. Paxata is looking at the entire million rows here, and that would be considered a relatively small data set from a Paxata perspective. We can operate on tens of millions, hundreds of millions of rows because we are backed by a technology called Apache Spark. I certainly don't want to get too technical in this demonstration, but we can scale out to the capability or the capacity that you need for your data preparation needs. Of course, we can sample as well, but I think it's very, very interesting that we can scale out to the amount of data that you're going to want to use, and you choose the amount of data if you do indeed want to sample. So the reason I bring that up is I have confidence now that across my entire data set, I have a minimum of 5 columns if I'm splitting on this underscore, and I also have a maximum of 5 columns, meaning that it's very consistent. So I don't have to worry about, well, maybe there's a data set that, or maybe there's a row or a few rows that have an extra underscore. So what's going to happen then? And we can address that, and there are numerous different ways that we can do that if we were sampling, but because we're not, we don't have to worry about that conversation today. I'm going to go ahead and change these columns to something that makes a little bit more sense. And you can see the speed of thought interactivity I get back from Paxata. So I'm just changing this. The final choice I have here to make is to whether or not I want to keep this campaign column as is, or whether or not I want to replace it with this data, because this is the actual campaign data. So by naming the column exactly the same thing, basically saying to Paxata that, well, I want to overwrite my original campaign. So you can see now I have much more granular information, so I can check very quickly, am I only looking at 2019? One unique value in the filtergram? Yes, I'm only looking at one unique value, so that's 2019. Maybe I'm interested in specific regions and specific channels, so I can see the distribution across all regions here for these channels. But maybe I'm interested in the distribution, particularly for APAC. So you can see that distribution sort of stays similar, but as in VP is the most commonly marketed to channel. But you get more intelligent about the data that you're looking at once you're preparing it, once you're drilling down on certain things. So I can make I can actually make selections based on filtergrams, and you can see how they interact with each other. So I'm now just looking at all of the VP and direct channels in APAC. As soon as I close these filtergrams, I'm looking at the entire data set again. So I'm looking at the entire data set, which is what I want to do. And the next thing that's standing out that is a problem is this send date. The problem with this is that it's a date, but it's in a text column, a text formatted column. So if I create a filtergram on this send date, it shows me the 252 unique values, which is fine, but I want to drill down on this slightly differently. So if I close this, I'm going to use the drop-down menu again and perform a change into. So I'm going to change this into date. I'm going to use one of the predefined date formats, and I can see that it's got time zone information, hence why I chose this particular one. I can see that it's successfully converted this into a date type field and confirmation, because it's turned green and I've got this little clock symbol. Now, if I create a filtergram on this clock symbol, interestingly, what will happen is I get to see this on an X and Y axes now. So I get to see it on a timeline. I can see most of my data is in 2019, but for whatever reason, there is some erroneous data in 2016. So I'm going to select that, and I'm really not interested in it. So I'm going to click the remove button to actually remove this from my data set. As soon as I click save, this data gets removed and the filtergram gets regenerated, and it really focuses in on the data set that I'm interested in. So I can see here I've got things from January to September in 2019. There's various different ways that I can look at this data. So there are different charts available for me so that I can look at this in different ways. And that can be interesting because maybe I'm only interested in Saturday and Sunday. Maybe I'm only interested in weekends. So by selecting that, I'm now just drilling down on the weekends in this data set, and any transformations that I apply while this filter is active will only be applied to the weekends, or maybe I want to export this out for whatever reason. Again, I'm going to close this data, but I will just draw your attention to the fact that October, November, and December are missing in this data set. So I'm going to address that in just a moment, but I'm sort of getting a little bit ahead of myself. So I just want to point that out because we will address that at some stage. if I continue looking across and sort of going from left to right in the data set, there's this embedded space in last name, and I get to see that pretty clearly. So what I'm going to go ahead and do is use the drop-down menu again and use this trim leading and trailing. And what that's going to do is just get rid of the leading spaces in the last name. I can apply these transformations to multiple columns. So in actual fact, I'm probably not interested in any spaces in any of the columns. So I'm just going to apply that to all of my data set and all of the columns in my data set, and just click save. And so now I don't have any spaces in the last name or any of the other columns. Company looks like it's blank, so I might want to remove it. So I'm just going to click quickly to see if it is blank, and I can see that no, it's not. So I won't remove it. It is largely blank, but there are some bits of information in there, so I'm not going to remove it. As I keep on scrolling across, I can see here that I've got email, and I also have name of person. So obviously this data, this web campaign data, has been augmented by someone else previously. But what I'm thinking now is what I want to do really is understand, and just so you can see the entire data set, if I scroll all the way across to the right-hand side, you can see the information that I've got available, as in how many times we've sent it to this person, how many times they've opened it, the clicks, if it's bounced, and if they've unsubscribed. So what I want to do here is actually join in some Salesforce data, because I can see that these are leads that we should have in Salesforce. So a very common use case in any data preparation activity is joining other data sets in. And so I'm going to perform this attach capability, which is I can either append new data, and we'll look at that in just a moment, because this is really looking at very, very similarly formatted data sets, or perform a lookup, which would be appropriate from a Salesforce perspective. Now, I don't have the Salesforce data in here, so I'm going to go ahead and import the data. And so this is a brand new screen that you haven't seen yet, but this takes advantage of predefined connectors. And I think that this is a really, really important point to the democratization of this process. Irrespective of the data set or the data source that I choose, we want to make sure that it's a very consistent, very uniform process. So while you can create queries, and Salesforce, you can create queries if you've got the technical expertise, you don't necessarily have to. In fact, I've got these Salesforce.com leads that I'm going to bring in. There are various parsing options that I've got available here. But I can see very quickly that if I scroll across to the actual data, I can see that, yes, these are the leads that I was expecting, and so I want to bring these in. Irrespective of whether it was a relational database, and we'll look at connecting to Snowflake in a minute, or if it was an S3 bucket or an XML file or a snappy compressed Parquet formatted file from an HDFS environment, you don't need to know any of that. And I think that's really, really significant. You can connect to any of the data sets that are important for your particular role. And then once we connect to it, we can quickly bring it into Paxata. We can select it. In this case, what I'm doing now is I'm joining two data sets together. So what I really want to do here is say, select the best foreign primary key relationship. Now, if I'm a domain expert with maybe not as much relational knowledge, relational database knowledge, I might not know what a foreign primary key relationship is. Or even if I am familiar with that, I might not be that familiar with the data sets themselves. So what I'm going to go ahead and do is click this Detect Joins button. And what that does is it looks at all of the data in my initial data set A, and then looks at all of the data in data set B, which is my Salesforce leads, and then works out what the best overlap is in relation to the actual data itself. So it's completely ignoring the metadata. And you can see here that it's come back with a 92% match. I think more impressively too, it's actually spanning multiple columns. And this is really, really useful. Particularly, I was did some work with a medical device company in the States. They had product numbers that were split across multiple fields in some data sources. In other data sources, they were concatenated. And so by joining data sets together, we found some interesting relationships that weren't previously known. So here we've got last name and first name matching to the full name of my leads, which is really, really useful. Now there are different options that I can choose here too. So I can change the cardinality of the join. You can note here that the diagram here is really, I think, really interesting. I think that this diagram in itself taught me more than a semester of Database 101. So I can do a left join, I can do an inner join. So if I want to only keep the data that matches, I would do an inner join. If I wanted to keep all of the leads and only the things that match those leads, I could do a right lookup, or I could do an outer join, which would keep everything. In this case, I'm going to keep a left join, and that'll be obvious in just a moment. And then the other thing that I want to point out is that we can control whether this is exact or whether it's fuzzy. In this case, it's an automatic type match. I can change that to exact if I wanted to. But you can see it's not quite exact because it's still catering for this comma. Now that, in this use case, is a very, very good thing. So I'm going to go ahead and save this, but I could change that behavior if I wanted to. So you'll note that this row here hasn't got any matching reference data, or it's not a matching lead. Same with this data here. So I've got some leads in here that aren't in Salesforce, which is interesting to me. And so I want to address that. So that's what we're going to do next. At the top of the data set, you can see the data set that I've just brought in, my leads, is purple, or sort of this light purple color. My original data set is dark purple. And if I scroll all the way across, you'll notice that I have this color-coded sources column, which becomes really, really interesting now that I've joined multiple data sets together. So you can see I've got the data that's matched and the data that hasn't, and I can create a filtergram on this as well. I can say, well, I'm only interested in the things that haven't matched, because these leads aren't actually in Salesforce. So I actually want to go and address that right now. And so this is something that's new that I haven't actually explained before, but I think it's pretty important. So before I explain what we're looking at here on the left-hand side, which are the steps, I'm just going to create a publish point and call this new SFDC leads. And I'm going to publish them out. And this is the first time I'm actually physically creating anything. So I'm just physically creating these 50,000 records in Paxata, which we can then forward on or export or do whatever we want to. Now, the other thing that I want to show you, now that I'm closing this filtergram and getting back to the entire data set, is this steps editor is capturing absolutely everything that we're doing in Paxata. So if I go back to the start step, you'll notice that the campaign column looks a bit of a mess because we cleaned it up. You can see the date is like it's been untouched. It's still in text format. You can see the spaces. So as we go through the steps, you'll notice that if I go to the split step, it applies the split. Of course, I can edit any of these as well. So if I wanted to and make a change to this, I could go and click on edit, and I would be able to change this. But the point here is that it makes it very easy, if I were to pick up this project from a colleague, to very quickly understand what they're trying to do with the data set, as opposed to looking at Python code or a SQL script to try to sort of work out what they're trying to do. This makes it very, very easy for me to collaborate with other people. Additionally, I can actually also annotate any of these steps, so I can make it even easier. Now, one of the other things that we noticed was that in this quarterly information, we were missing Q4 data. Now, I happen to know that that resides in Snowflake, so I'm going to go ahead and append some data from Snowflake. So using this, and I'm going to keep the steps editor open here for a moment, and that'll become apparent as to why I'm doing that momentarily. I'm going to perform the append, and an append is like a database union operation where I have very similarly structured data sets and I want to stack them on top of each other. So here I'm going to import data. As I mentioned, I'm going to use the Snowflake connector. So if I click on Snowflake, I'm going to go ahead, and by the way, just to prove that this is, I am connecting to Snowflake. This is just my Snowflake console. I have a schema set up in my name, and I'm going to be bringing in some Q4. So I've got this 2019 Q4 web campaigns data. So if I now select Snowflake, I'm going to select the demo database, my schema column, and then I'm going to select the Q4 campaigns. You can see it's 337,000 rows. I can see the campaign information. So it looks very similarly structured to my original Q1 to Q3 data, which is good, because what I'm going to want to do is once I bring these data into my project, I'm going to want to reapply all of the steps that we've performed on the Q1 to Q3 data on the Q4 data. So the fact that I'm appending this right up the top here means a couple of things. It means that I'm not looking at, well, I'm trying to append it to all of the Salesforce data that I joined in as well. So you can see there's a lot of mismatching columns because we've joined in this other Salesforce data set as well. There are 14 matched columns though, and this is matching by name, which is really useful. And let me sort of further explain that very briefly. But if you look to the bottom of the screen here, you can see very clearly that at about the million row mark, you can see I've got my data from Q1 to Q3. I've got my light purple data from Salesforce, and then I've got my Q4 data in green. And unsurprisingly, we haven't applied any of this split. We haven't applied the date change here. We haven't applied any of these because they've all been applied before this append step. So what I'm going to do very, very quickly and easily is just drag this append step down and perform the append as the second step. One of the really nice things here is that now most of the columns do match, but some of them don't. I can see in my Q4 data, I've got something called drop date, which I don't know what it is. And I've got something called last, and there's no matching field for last name. So what I might want to do is just sort of validate that, well, last name appears in Q3. So I can see that Q1 to Q3. And in Q4, it's got something called last. So if I scroll all the way across to the right-hand side, I can see that there's last here. So there's been some sort of minor schema change, which isn't a problem. I'm just going to go and marry these columns up just by selecting the drop-down last, and you'll notice that this now gets populated. I'm going to go ahead and save this, and then very quickly apply all of the previous transformations, not just to my Q1 to Q3 data, but my Q4 data as well. So if I scroll across now, you can very quickly see that my Q4 data is now being handled exactly the same way. So here I've got the things that matched in Q3, the things that matched in Q4 or Q1 to Q3, the things that matched in Q4, and then the things that didn't match. So maybe I want to actually update this new Salesforce leads with the Q4 data. I'm not going to do that just for the interest of time because there's a fair bit more that I want to cover. But hopefully you can see how we've applied all of those transformations now to both data sets, and it's a very flexible approach to that data transformation. Now, one of the things that I talked about was feature engineering, and something that AutoML is very, very good at. One of the things, though, that I want to sort of point out is that there is the capability to do some of that feature engineering in Paxata, particularly when you've got business information that you think is going to be interesting. to create signal for a training model. So here we have a computed column, and I'm going to click compute. And I'm going to use this in conjunction with the sent date, because I want to have a look at the age of campaign, or the number of days since we sent it on. So if I go and say, in this particular computed column, I want the date difference between, we had a date over here, the sent date. I want the date difference between the sent date and now, and I want that in days. And by the way, this context sensitive help is really handy, because what you can do is when you turn it on, it just shows you what it's expecting. So date diff is expecting 2 dates and an interval. So I've got 2 dates and an interval. And if I scroll all the way across to the right-hand side, I've got the number of days since this campaign was run, because I think that could be something that's interesting from a feature perspective. I'm going to click on save. This is sort of as technical as Paxata gets, the computed columns, but if you're familiar with Excel, then that's something that you'll be able to do pretty easily. One of the other things, with the fact that I've now got Salesforce data joining in here, one of the interesting things about Salesforce is the challenges with data quality, and anyone who's used Salesforce can probably testify to this. In this case, if I perform a filtergram on company name and just do a search on JC, I can see that I've got 4 different JC Penney records here, which is just showing me that I've got variation in the data. There's probably other variation as well. And so what I'm not going to do is manually change these. What I am going to do is, using this drop-down menu, is perform a cluster and edit. So cluster and edit looks at all of the different phonetic variation, because I'm using a metaphone strategy. Actually, I'm going to close this steps editor just for the moment, just to get a bit more screen real estate. But you can see here that it's saying, well, based on a metaphone algorithm, these 3,471 rows distributed across these different 4 variations make up this JC Penney record. Now, I've got 190 different clusters that I can select, so I'm not going to go through each and every one of them, but you can see some of the variation that it picks up, and some very, very powerful things. There are a number of different approaches, because metaphone can be a very permissive algorithm, so sometimes you want to be a little more conservative. And fingerprint is a fantastic algorithm for that, because it just looks at the variation from a word order perspective, and any extra punctuation or common words like and, ink, and things like that. So if you wanted to be very conservative, you could use fingerprint, and then somewhere you've got a lot more control with ngram. This is a part of the platform that you can actually extend. So we have customers that have created their own algorithms here. But in this case, I'm going to go ahead and select the 190 clusters automatically in the interest of time. And I'm going to go ahead and save this. So here I now have a clean set of data ready for training, ready for my DataRobot machine learning to create some models for me. You'll notice here, if I create a filtergram on here, instead of having 6,300, I've now cleaned this up to 6,100, which is pretty significant. So as I said, I want to create a training data set. And if I open my marketing analysis here, I'm going to create a new lens, because I'm interested in creating a training set, but I'm only interested in a subset of the campaigns. By the way, actually, before I do this, I'm going to cancel that. Before I do this, if this was a real world scenario, I'd go through and deselect a lot of these columns, because there's a concept called target leakage from a data science perspective, and pretty much all of my Salesforce data I'd probably want to get rid of. So I'm going to get rid of all of the columns. And in actual fact, there is one very, very important step that I'm missing here. So I'm actually going to cancel this as well. What I want to do is actually create the feature that I'm interested in, and that is whether someone has been converted or not. So the fact that I've got Salesforce data in here, and I apologize that I'm clicking around a bit, the Salesforce data that I have in here has a column called status. And so this is the last thing that I'm going to do to create my training data set. The status has a lot of different things, but the status has converted and rejected. Now, converted is the thing that I want to predict, and rejected is the thing that I want to obviously avoid. So I'm going to now just remove these assigned in progress unassigned values, because this is they're essentially the values that I want to predict whether they're going to be eventually converted or rejected. So I'm going to get rid of this. I'm now left with just two values, which is rejected and converted. Converted being the thing that I want to predict. And I could create an if statement here in the computed column, but what I'm doing is actually saying, let's just create a 1, because I'm using it in conjunction with my filter. So I'm just saying, if something's converted, put a 1 in this column. As soon as I clear this filtergram, I now have some blanks in here. So I'm going to double click on this cell and say, well, whenever there's something blank in here, it's obviously rejected. So I want it as a 0. And so this is going to be my target from a training perspective. This is converted. And again, to address that target leakage, I'm going to remove all of my Salesforce data for my training. And then I can click save. There's probably a couple of other columns that I may want to remove, but actually DataRobot sort of gives me a report on any potential target leakage. And so I'm going to say I only want certain campaigns. So I'm going to say, let's say content is king. So I want a specific model to predict where content is king. I save this, I publish it, and now I can show it in my library. Now, I've really been focusing on importing data into Paxata, but one of the things that's very, very important to us is that it should be as easy as possible to get data out of Paxata as well. And so this is sort of where I'm switching to in the demonstration now. I'm going to export this training data, and I have a lot of different options here, but one of them is my AI catalog in DataRobot. And so in this AI catalog, I'm going to select it. I'm going to say marketing analysis, training, content is king. I'm going to export it, and I can see if I move to my DataRobot interface, if I look at my AI catalog, you can see that this is registering now. Now, it won't take very long for this to register. And ordinarily, I would love, if we had another half an hour, I would love to show you how I would go through this completely end to end by creating a project on this data set, creating some models. But like any good celebrity chef, I've done this before the show. And so what I've got here, you can see up the top here, I've got a previously run project, and I've previously run my auto predictions, or rather, sorry, my automatic training of the models with this training data. And I have I've deployed a model in my deployments. So if you're not familiar with DataRobot, some of this might look a little, well, will look unfamiliar, but I would like to encourage you certainly, and even if you don't have a data science background, to certainly reach out and have a demonstration of this, because it's really, really powerful stuff. Essentially, what I've done, I exported some training data into DataRobot. I created a project. I clicked start once I selected the thing that I wanted to predict, which was my is converted. I selected the model, and then I deployed it. So I realize I've fast forwarded over a whole lot of stuff, but if I take you back to the actual presentation, we just spent the majority of the time doing this. We did a little bit of this as well. But then I've just fast forwarded through the DataRobot stuff, the model building, the exploring models, and the evaluating models, and then deploying it. But I have explained how you could do it, or how I did do it. So the final step here is to schedule these predictions and to populate a Tableau server with those predictions. And I'm going to do that all in Paxata. So if I go back to my project, and all within 10 minutes, because we only have 10 minutes, I'm going to create a copy of my project. And this is going to be called Marketing Analysis Predictions. If I can type. I'm going to copy it, and I'm going to use this to predict. Now, the first thing I need to do is I want to get rid of this lens, and I also want to get rid of a couple of other things. So I want to go back in time, and I want to get rid of this is converted, because obviously that's the thing that we're trying to predict. And if I go back in time, I actually want to invert this the selection of this particular filtergram by getting rid of the values that we've used for the training, because obviously we can't use predictions on things that we already know. So if I save this, I've now removed all of the things that we previously knew about the data. And finally, the last thing that I'm going to do is utilize this prediction from DataRobot in Paxata. So I need to connect the two tools together. And then I choose the deployment that I'd previously created called isConvertedPredictions. Now, what this is doing is it's saying that this is my prediction converted. And I can save this, but I think this is really significant, because what I'm now doing is I'm taking advantage of the thing that I've just deployed in DataRobot, and I'm now looking, if I look at the filtergram, I can see which of these campaigns or which of these contacts are most likely to be converted. So as I generate this filtergram, I'm also then, once I select the things that I want to predict, I'm then going to create a lens to actually publish this out. One of the things that I'm not going to get a chance to demonstrate in this particular demonstration is the ability to, so I can see that there are a number of predictions, so 911, and so this has worked very, very well in the sense that I now have these 911 predictions that I can potentially export. So I can say, let's create a lens, and these are my positive predictions of conversion. I can publish this out. The thing that I'm not going to get to show you today is the automated flow. So we can set up a lot of this on a schedule. So when a data source gets updated, we can set that up on a time-based schedule to say run every minute, every week, every day. And then right at the end, to make use of this data, and this is again something that we're not going to be able to spend a lot of time on, but Paxata is rarely the end of the line for data, and that's why we have so many connectors to many other tools and many other repositories. One of those repositories is Tableau, and we have a number of other targets like Power BI, MicroStrategy, and various other relational sources, and you've seen a few of the others. What I'm going to go ahead and do here is just export some of this data directly to something. I've got a Tableau server here. So what I can do is actually go ahead and say, well, I want the Q4 web campaigns created here. Now we have a hyper connector and we have, sorry, let me try that again. The reason this failed is that Tableau doesn't like anything other than characters in the file name. So here, what I'm going to do is use this exact same data set, and this time it's going to work. But the significance here is that I can very easily populate a Tableau server. So if this is my Tableau server. If I refresh this, you'll notice that I've previously uploaded this marketing analysis predictions. That was just this morning. Once this completes, which I'm not going to spend too much time waiting for it to complete, it will be here available for me to use. You can see it's here, it's just been updated now. But the last thing that I wanted to show you is that it makes it very easy to connect, and this is something that I prepared ahead of time. So it makes it very easy for me to add a data source to here. And so you can see it, the Q4 web campaigns happened 0 minutes ago. But it makes it very easy for me to repopulate this Tableau workbook based on the data that I've gleaned from both Paxata and DataRobot. And the other really important thing that I want to leave you with is that sometimes when you're in a Tableau workbook, you want to know what the underlying data is. We have a connection to Tableau called click to prep. So if I was interested in, let's say, the demo campaign, if I click on this, you can see I've got a Paxata drill down. And this is something I set up previously, but I've pointed it to Paxata. So what it's doing is it's saying, take me back to the preparation that we've just performed, and here I can then go in and select the specific thing. In actual fact, it should have, if I try that again, it will filter down on the specific data, or it should do. I've obviously not configured it quite correctly, but it makes it very, very interesting to be able to go from the visualization and the BI tool to be able to understand, okay, well, if I'm only looking at the demo information, why was I seeing X in Tableau? Well, you can see that by using filtergrams, you can see that very, very easily here. And perhaps that dictates what you then want to add to this preparation flow. So it's extremely flexible, very versatile. That's what I wanted to show you today. I really appreciate your time. I would encourage you, if you do want to try out Paxata or DataRobot, to please contact me or the team. I can be contacted. It's just callum@paxata.com or callum@datarobot.com, either one. Would love to set you up with a trial of Paxata if it was of interest, or just chat to you. I, again, appreciate your time, and yeah, thank you for your attention, and happy preparing data.